In this video, we're going to talk about the segment addition postulate. So first, let's talk about what a postulate is. A postulate is a statement that we're going to accept without proof. So this would be something like, if today is Tuesday, then tomorrow is Wednesday. It's just something that we accept and we don't have to actually go ahead and prove it. A theorem, on the other hand, is something that can be proven, and we're going to prove a lot of theorems throughout the year in geometry. Now, just to remember from the last lesson, and you can watch that lesson here if you haven't seen it already, the word collinear is referring to if you have more than 2 points in a row or in a line. And if 3 points are collinear, you're going to be able to conclude that one of those points is between the other two. Between in this case does not mean in the middle. Okay, so the segment addition postulate is something you've been doing your entire life. I'm going to draw a little picture here. If you start at your house and you're going on vacation, you drive 200 miles and you realize, oh, somebody has to go to the bathroom. You stop at the bathroom. Once you are done in the bathroom, you drive more. And let's say you drive 150 miles to your vacation destination. You will have driven 200 plus 150 miles, and you will have driven a total of 350 miles for your vacation. This is the segment addition postulate. Now, in letters, if I'm looking at this segment, I would say that the distance from H to B plus the distance from B to V is equal to the distance if you had just driven straight from H to V. So how do we use this in geometry? Well, here, let's take a look at a few quick examples here. Let's say you drove 54 miles and then you drove 89 more miles. You would just add up these two distances and get a total of 143 miles. Doing the reverse, let's say you knew you drove a distance of 52 units in this case. If you know that on the back end you're going to come 16 units, you can take 52 minus the 16 and say that the distance from K to L is equal to 36. So algebraically, how are we going to incorporate this into geometry? If you look at this diagram, it tells you what CD, DE, and CE are, but it's not labeled for you on the diagram. So the first thing you're going to have to do is label the diagram. Now, the segment addition postulate says that if you add the two smaller distances, it equals the total from the entire segment. So what I'm going to do is I'm going to add together 8x plus 3x. I'm also going to add together negative 8 and positive 3. And so on the top of this line, I have 11x, positive 3, and negative 8 is negative 5. And I'm going to set it equal to 4x plus 37. So now this becomes a very workable linear equation. I'm going to take away 4 on both sides. That's going to give me 7x. I'm going to add 5 to 37 and then get my final answer of 6. It wants me to find DE, so I'm going to take 6, substitute it in. So instead of saying 3x minus 8, I'm going to say 3 times 6 minus 8, which is 18 minus 8, which is 10 as my final answer. For my next question, there is no diagram. So I'm going to draw a diagram where B is between A and C, and it doesn't really matter where you put B, you're just getting a visual. The next thing I'm going to do is label the diagram with the information that I'm giving in the problem, and then I'm going to set up my equation. So on the top of this segment, I know that I have x and 2x minus 3, and altogether that has to equal 30. So x and 2x is 3x, minus 3 is 30, 3x is 33, x is 11. And then I'm going to take my 11 and substitute it in for BC. So 2 times 11 minus 3 is 22 minus 3, which is 19. The next question says, in segment CT, A is between C and T. So we're going to draw a picture here of C and T. A can be anywhere in between. And then we're going to label our diagram. CT is equal to x squared. That's the entire thing. CA is negative 8 plus 4x, and AT is 3x minus 4. So using the segment addition postulate, we're going to add together those top two segments. So you're going to have negative 8 plus 4x plus 3x minus 4. The 4x and the 3x is 7x. The negative 8 and negative 4 is negative 12. We're going to set it equal to x squared. As soon as you see this x squared, you're going to have to set this up to factor. So one of these sides is going to have to be completely set equal to 0. I would like to keep my x squared positive, so I'm going to take away 7x and add 12 to both sides. So when I do that, I'm going to be left with my final equation as x squared minus 7x plus 12 equals 0. I need to factor this so that I'm looking for factors of 12 that are 7 away from each other, or could make 7 if you add them together. And the only two options in this case are going to be 3 and 4. So I'm going to break this down into my parentheses and say that x minus 4, and x minus 3 are the factors. And then I'm going to take both of these factors and set them equal to 0. So I'm going to get two options. X is going to equal 4 or x is going to equal 3. And I have to make sure that since I'm in geometry, that if I substitute these numbers back into either parts of this expression, that my distance remains positive. So for example, if x equals 4, the question wants you to find CT, and CT is just equal to x squared. So if x equals 4, then CT is going to equal 16. And if x equals 3, then 3 squared is 9. That's all for this video. As always, if you found this video helpful, make sure you hit like and subscribe. You can find this resource along with many others on my Teachers Pay Teachers, which is Math with B.